Hi, everybody. Similar to Tuesday's worksheet where I did two problems and then you guys did two problems. This worksheet here, I'll do two problems at the top and you'll end up doing four problems on the bottom. This is organized where the two problems on the top match up with its column. So the easiest problem is A, and it matches up with problems 1 and 3. And the medium problem is B, and it matches up with problems 2 and 4. Okay, so let me zoom in here. Oops, to the top. And let's go over problem A. So in a parallelogram, we know things about its sides and its angles. And if you don't know these setups completely, for example, if there's some things with angles equaling 90 or 45 or 180 you're not sure about, go back to yesterday's assignment. It's going to be graded. You'll have the answers and you can set them up. Problems 1, 2, 3, and 4 all from your assignment. But for this first one, opposite sides are equal. So the top side, x plus y, equals the bottom side, 20. Same thing on the angles. The bottom right angle, x plus y, equals the top left angle, 52. Now, it's important that when you do these problems today, you always write them in standard form. Your x term first, your y term second, and equal sign third, and your number last. For the easiest problems here on the left, all you're going to do is add them. There's not going to be any extra steps you have to take. When you add them here, something will eliminate. Like here, negative x plus x adds to 0. So it's eliminated. Y plus y, careful, is 2y. We're adding. And 20 plus 52 is 72. Divide by 2, divide by 2. We get y is 36, and we're halfway done with the problem. And then we're going to plug it back in, and you can plug it back into any equation you want. I'm going to choose to plug it back into x plus y equals 52. No negative signs to stress me out. X plus, plug in the 36 in place of y, because it's y that I'd found. If I'd found x first, you plug in for x, equals 52, and then a subtraction step, and we're done. And we get x equals 16. You'll find problem 1 on the left and 3 on the left should be just as easy. Problem number 1, set the two diagonal pieces equal and set the two angles equal. Just make sure when you set the angles equal, put the negative x plus 5y first so you're writing it in standard form, and it should be that straightforward. In a square, you're going to see that the y's will cancel out very well. Careful to set the sides equal. And then careful, that angle on the bottom doesn't have a second angle to set equal to. What do you know about angles in a square? The whole angles are 90 in the corners, and then the diagonals bisect that angle, so take half of 90, and that's what the 2x plus y is equal to. Again, if you're not sure about this, even after watching the video, you can go back to your answers from yesterday's assignment, which you'll have in a moment if you search for them on your exam login. All right, so hopefully problem A makes sense, and problems 1 and 3 should go quickly. Problem B can be done a couple different ways, but just like the last problem, sides are equal. I'm going to make sure to write x minus y first, equals 1. And angles are equal. Negative 5x minus 3y equals 19. There's two ways to do this problem to start. What I'm going to do is show you one way first, and then I'm going to erase it on purpose to show you a little bit tougher way to cancel things out on purpose. But one thing I could do here is I could cancel out the x's. Since I have negative 5x on the bottom, I could distribute a 5 and write positive 5x minus 5y equals 5. What I just did there is I added I multiplied the 5 times each term on the top equation. 5 times x, 5x, negative y times 5, negative 5y, 1 times 5, 5. You could just add now And when you add them, you would get the x's to cancel, eliminate. Negative 3y minus 5y is negative 8y, and 19 and 5 is 24. This method works fine. There's a reason why I'm going to erase all this work here now. Because I want to make sure you can do a harder problem like number 4. Number 2, you could do just like this method. If you look right now down the bottom, you see the 4x minus y, you see the 3x plus 2y. You could just multiply the top equation, the 4x minus y equation, times 2, and the y's will eliminate just as easily as the x is eliminated in this problem. But now I'm going to erase all this, and there's a reason why. So here I go, erase and get back to my equation. Not only could you eliminate the x's by multiplying by 5, you could eliminate the y's. And the easiest way to eliminate the y's, in my opinion, is to multiply it by negative 3. Why am I doing this? Well, if you distribute to all the different things, you will get negative 3x plus 3y equals negative 3. Now look at the y's. We're going to add these equations together. Negative 5x minus 3x is negative 8x. Negative 3y plus 3y adds to 0. It eliminates the whole purpose of this. And then 19 minus 3 is 16. All right? Divide by negative 8, divide by negative 8. You get x equals negative 2, and you're good to go. And now you'll just re-plug it into any equation you want. Doesn't matter which one you choose. I'm going to choose the negative 5x one. Negative 5x minus 3y equals 19. I could have chosen any of the other equations. The reason I'm doing this is I glanced at it and I thought this would be the easiest one to understand without negatives causing too much problem. I could be wrong. Negative 5 times negative 2 is 10. Minus 3y equals 19. Subtract the 10 from both sides. Get negative 3y equals 9. Divide by negative 3, divide by negative 3, and we get y equals negative 3. It's a little weird to see both a couple negative answers for x and y, but if you plug them back in, you would get x minus y equals 1. Makes sense. The left side equals the right side. And if you plug things back in, it does work out to be the bottom left angle is 19 degrees and the top left angle is 19 degrees. When you set up number 2, it'll be easy to eliminate after multiplying. You'll just have to multiply by the correct number. It should be pretty easy to eliminate the y's. For number 4, you can see they're all positive signs. So you have to figure out how to set it up. First of all, careful that 36x plus 18y, it's an angle. How many degrees is the angle in the middle there? 36x plus 18y equals that angle number. And then the side, 3x plus y equals 7. You'll also eliminate the y's. Carefully, you have to multiply it by a negative 18 to eliminate the y's, because you'll have the positive 18y from what's printed in the problem. So you'll multiply by negative 18 to make it negative 18y, along with multiplying negative 18 times the other numbers. Distribute to all 3 of them, and things will eliminate pretty quickly. If you understand elimination, this should be a short assignment today. If not, you might have to ask some questions. If you're having trouble setting it up, like the stuff I wrote in blue at the very beginning, before I did any multiplying or any elimination in green, please take a look at the answers from last assignment. But if you're having trouble with any of your steps of solving, please seek out some extra help, whether it's going back to last week's stuff on IXL Algebra 1 U.10, or whether it's just simply going back to any of the old worksheets, or seeking me out, asking a question, trying to get some help online. Obviously, today's Thursday, so this will not go in the grade book until Monday overall. So if you need some extra time over the weekend, take some extra time over the weekend. Next week, we're going to spend some time on how do you decide between substitution and elimination, and review. And then we're already close to the end of the school year now. 2 weeks from now is our final assessment. It's not like a final exam. It's not even like a cumulative fourth quarter exam. It's just going to be an assessment on this topic. Can you do substitution and elimination with quadrilaterals? Can you set things up? Can you solve them? Take care, everyone. Seek me out if you need any extra help. Good luck today, and let me know if you need anything else.